displacement in the nth second of the journey or distance travelled in the nth second of the journey. A body starts from rest, accelerates uniformly. It covers as much distance in the last second of motion as it covered in the first 3 seconds of its motion. The body has travelled for a total time of. Okay. So, the description is here. It starts from rest. It covers as much distance in the last second of motion as it covered in the first 3 seconds of motion. So, t is equal to 0 and t is equal to 3 seconds. Let us assume that the distance travelled is S1. And he says it has covered same distance in the last second of its motion. That means, I do not know what is the value of n. So, n minus 1 to n, that is its last second of its motion. So, it has covered the same distance S2. So, I will write S1 is equal to ut plus half at square, that gives us u is 0. So, half a into 9, that is S1. Then we also have from the second part the distance travelled in the nth second of the journey is nothing but u plus a by 2 into 2n minus 1. U is 0. So, I have a by 2 into 2n minus 1. Thus, equation 1 and equation 2 are equal to each other because S1 and S2 are equal to each other. That gives us half a into 9 is equal to a by 2 into 2n minus 1. Let us simplify it further. If we simplify it further, a cancels, a by 2 cancels, we have 9 plus 1 is equal to 2n or n is equal to 5. That is right. So, now we have to find out the total time of the journey. The body has travelled for a total time. Now, it is easy. So, we know t is equal to 5. So, we can find out the total time of the journey. So, total time of the journey can be calculated using the equations 1 and 2 again. So, equation 1 and equation 2 give us the total time of the journey as t is equal to 5 seconds. N is equal to 5, that implies t is equal to 5.